Okay, lads. Another year 12 trigonometry lesson. So, uh, hopefully, you're all aware that the area of a circle is pi r squared. So, the area of a circle is pi r squared. Okay. What we want to understand is r, right? What we want to know is what is the area of a sector, so part of a circle. So let's have a look at that. These are both going to be a radius r. So if that is some angle theta, what's the area going to be? Well, that is theta out of 2 pi. So for my previous lesson, remember that a full rotation is 2 pi. So now we have theta over 2 pi as a fraction of that circle. So the area is theta over 2 pi times the area of a circle, pi r squared. Okay, so theta out of 2 pi times pi r squared. Now that simplifies down to, you'll notice that pi's will cancel and you are left with theta over 2 times r squared, and this is usually written a half theta r squared. So this is one of those 7 formulas you need for your internal. Now, be aware that this is in radian measure, right? Everything breaks down. If you took 100 degrees over 2 pi, wouldn't work. So make sure you convert, like from that previous video, you convert degrees into radians. So let's have a look at a problem. Okay, let's start off nice and easy. What could we do here? Let's say we have a sector. All right, we want to know the area of this thing. Let's say there's 1.8 radians and a radius of 5 centimeters. Then we just have to use this formula. A half theta r squared. So the area of this is a half times the angle in radians. We have 1.8 radians. And we times that by 5 squared. So on our calculator, that's going to look like 0.5 times 1.8 times 5 squared. And the area of this thing is 22.5 units squared. It's really that easy. Again, the hard part is solving for an angle given an area, solving for a radius given an area. And I'll be putting up some of those problems later on today. Let's have a look at just another one. So what if we had something like that? We want the area of this thing. And we know that that's pi over 3 radians in there, and that's 2 centimeters on either side. Well, what's the area of this whole thing going to be? Well, we need to figure out what the angle on the inside is. Remember, we want the interior angle. So that interior angle, remember, 2 pi goes all the way around. So if I take out pi over 3, I'm going to get 5 pi over 3. You can ignore the pi for now and just do 2 minus a third, and you would get 5 pi over 3. And now we can plug in. So the area is just going to be a half times 5 pi over 3 times radius squared, 2 squared. You can see how that's not quite 2 pi, is it? It's 5/3 of pi. So it's obviously a fraction of an entire circle. So this here is the fraction of the circle. Let's have a look. That is 0.5 for the half times 5 times pi, so you're going to have to go shift and get that yellow pi in there, and divided by 3 times by 2 squared, 10.5. 10.5 centimeters squared. We've got units now, so that's centimeters squared. So it's as easy as that. I'll do one more with degrees. Okay, so I'll get one that has, actually we'll do one where we have to find an angle. So what if we didn't have the angle but we had the area? So we take our sector, right? This is a sector. If we know it's 18 centimeters squared, and I want to know this angle given that its radius is 5 centimeters. Well, area is a half theta r squared, and we could rearrange this now. I might come back and rearrange this, but we know that 18, you can rearrange it before or after you put the numbers in. 18 is a half of theta times 5 squared. So to get rid of the half, we'd double both sides, because 2 halves is a whole. So we could call this 2 lots of 18. What's that? It's 36, isn't it? 2 lots of 18. 36 equals 25 theta, and then we're going to divide by 25. So 36 over 25 is theta, 1.44. And is that degrees or is it radians? And it is radians, so you want to write that down. Remember, you always need units. How many degrees is that? So I think we know that we convert 180 over pi is what we multiply this by. So multiply that by 1.44. .5. So that angle is 82.5 degrees, or it is 1.44 radians. So there we have it. That is today's lesson, and there will be some material coming onto the Google Classroom for you guys to practice a little bit of that. Cheers.